I'd like to introduce you first before you're going to start your presentation. So for everyone's expectation, so Jerome is from VMware, previously from Pivotal. So he's a forward-looking and innovative security executive with strong hands-on experience ranging from defining governance, re-engineering process, and implementing technical solutions. Driven by a deep passion for continuous improvement and challenging the status quo, Jerome believes in cultivating a balanced culture of business-driven security through operational effectiveness. So basically, we have a security expert also here from VMware. All right, so you can introduce yourself also if you want.
Thanks. That's a very pompous introduction. I forgot it was that verbal. Security expert, unfortunately, no one is, so but I've done my share of security. If I want to introduce me a little bit more hands-on, I'm a digital native. We're lucky to be in 2020, everyone. It's not negative anymore to say I'm born with a computer. I had my first computer, I was 4 years old, so I've done a little bit on computers. Ran Linux before running Windows, so kind of, you know. I like this stuff. I've tried being a developer and I've decided, I've realized I'm not good at it, so I should be maybe doing something else. But I do understand the challenges of but yeah, for the last 15 years, I've been doing security, mostly CISO and for a bank, and lately I was head of security engineering and the program of Prudential, a small insurance that you guys have above. And then I decided to join Pivotal after saying for 15 years I would never work for a vendor. I decided because I truly believe that what happens when you start doing cloud native and when you start fixing security as part of the IT processes, we really solve much more problems than whatever security vendors have been selling for years. That's really where I came in, and what I like is to really take a step back and say, okay, instead of talking about security, let's see how we can, by buying product and putting things into it. That's probably one of the issues I have with DevSecOps. But DevSecOps is basically software code, source code scanners, vendors who are trying to tell you, hey, let's put it in a pipeline. But if we really want to do security, we need to look at it from the core, right? And the core, and I'm usually saying that there's no such thing as DevSecOps. There is security well done as part of DevOps, but that's really a matter of talks, of words. If you go back to the basics of DevOps, really it's about fixing the fact that IT has been done wrong for the last 20 years. And he came to the realization that you need cultures, and we've all heard the accounts of DevOps, culture automation, leans. And again, the problem I have is that everyone focuses on automation. All the discussion around DevOps and DevSecOps is all about pipeline. Let's automate the controls. There's one more tool to do it. But the core of what makes DevOps and what makes it effective is two different things, right? First, to focus on outcomes, and so the 4 metrics of DevOps are well recognized now, but also changing the organization. You don't do DevOps if you still have dev in one corner and ops on the other corner and a team in the middle that just builds a pipeline that ship from one hand to another, right? DevOps requires a change of organization, and I'll come back to it. If you look at really what the industry considers as DevOps is getting people together of different expertise around the table to solve those 4 metrics. Improving lead time, which is really about how long does it take from the moment you have an idea to the moment you actually ship it. So that means organizationally, what's your process for making a decision whether you're allowed or not to work on it. Provisioning your dev environment, provisioning your everything, right? And the slides earlier were showing, oh, it worked in dev, it's not a problem right now. And it's a problem we have in security, right? Because we do security and we are so stringent on production, We also say, developers, you do whatever you want. And so develop in an environment that is working, and then you push to UAT and it's not working, but not that you do. You go to production, you have 1 day to put it in production, and everything is broken. What happens? We put exceptions, right? And that's a real challenge of what we have in security, and all the problems we have are just because our IT processes are broken. So we go towards development frequency, and again, it requires different teams to work together. You can't achieve any of those 4 outcomes by one team alone. It requires a change of organization and things. What I really love from a security perspective is the focus on change failure and time to restore. Because yes, in security, we're all afraid that if you ship 10 times a day, you're going to put crap in production 10 times a day. We all say it, and we actually agree. But if you work towards getting code that is so clean and pipelines that are so clean and so well done that you are confident that you're going to ship something that not broken, then that means you have better quality of code. And in Pivotal, we've practiced for years pair programming and test-driven development, and we've seen it. We have customers who ship code several thousand times a day, a month, and do the 5 nines of doing efficiently. 99.999% of the time they change something in production, there is no single impact. And that's what really happened and what unlocked security, because that also means if you want to apply a patch, you can do it without any fears that you're going to break anything. If you want to fix code, you can do it without breaking anything. So the discussion towards let's fix the vulnerability once we find them is much easier, different than what we have. But ultimately, what we want is incident management, right? And that's really why I really focus on the full cycle, and I think it's extremely important not to forget the ops part of DevOps when you talk about security. Because at the end of the day, that also changes who is responsible for security, who is responsible for finding the anomaly and working on it. If you look at Netflix, the security team doesn't really do that much investigation. What they do is enrich the analytics tools of the developers so that the application team are able to detect security attacks. And that's really where you need to change a lot of the practices and where you have better security outcome. So early on DevOps, we had 2 very famous DevOps leaders. Amazon, I think, is undeniably recognized as one of the companies who knows how to ship code. And that's really the core of it. Is the whole idea is that you develop and you ship it to someone else to run is absolutely stupid, because that means you don't know if your application runs well or you don't actually learn from it, so you can't actually improve. That means DevOps is really about you run dev and ops and you're responsible end to end. And that's really what John Olspo, who actually started the whole DevOps, was pointing out as well. But then the main question is, does it mean security as well? Is our DevOps responsible for security as well? So we've talked and we've seen most of the implementation that change is really about creating a team that runs dev and ops and whoever is required to develop better apps application. That also means, yes, you need to put security available for the DevOps team. And that's really, if you think about it, why people are promoting security champions. I hope you have security champions, because we don't have enough security guys to be sitting in every team. You don't need security people constantly on every project, but you need to be able to help and to have the discussion, right? But the main challenge is, how do you scale? If everyone does AWS in one way and builds the whole stack and manage the whole stacks, and 1, 2, 3 projects, it becomes very quickly unmanageable. So the main question of security or DevSecOps is really, how do you build consistency across all the teams? And that's really where you see 2 approaches to it, right? So some of them are trying to do I am responsible and I build everything. I do my templates, I do my operating system, I configure my Kubernetes, I configure my Docker file. So the problem you have here is that you need full stack engineers. First, very rare. Second, very high chance of making security mistakes. And let's be honest, if you want to do something that is secure, it's hard. And what you want is your developers to focus on the quality of the product from a business perspective, not really on configuring Tomcat servers, key rotation or also certificates, right? For years, we've seen the same forms being sent across, and no one can actually answer all the questions because security is very pervasive. So if you look at what the cloud companies have started doing is to build their platforms. Netflix is very famous for the paved road, which is, okay, let's not block any developer to do anything. What we're going to do is to build a pipeline, to build an environment, so if you run a Java application, all the security is already in. You don't have to care about security because identity is taken care of, monitoring is taken care of, all the security aspect and all the encryption is taken care of, so you can focus on what really matters, right? So you do your threat model and you identify the risk instead of having to deal with a full stack of compliance, operating system, and Tomcat. So you build those platforms so that product teams can focus on code, application. And that's really where we are today. If you look at cloud native architecture, it's really decoupling completely infrastructure security, which is a non-issue today, if you do the right thing, and application security, which is what we need to focus on, but honestly, in security, we never have the time to do it because there is so much stuff to do. And so, we know it, DevOps has improved productivity, but so what about security? If you hear about Pivotal, you know that we are advocates of cloud native architecture, and you can do cloud without doing cloud native. That's a kind of a pity. Serverless is kind of the extreme of cloud native, but that's only for a specific edge case. Really what you want is an immutable infrastructure that is distributed and ephemeral. Immutable, that means no one ever touches anything. From a security perspective, we love it. That means it's auditable. That means no one ever connects and changes anything. You don't have guarantees that everything is configured the way your Git repo is says it does, right? So auditors, you can send them and say, hey, go scan my configuration files because everything that runs in production is the case. If you do distributed infrastructures, that means you're preventing outage. That's great, but that also means from a security perspective, we can patch at any point of time. And honestly, that's still today the #1 reasons for breach. We love to talk about nation-state attacks and all those very advanced APT, but still the vast majority of attacks have to do with very simple known vulnerabilities that were not patched because we have failures there, because we have very tightly coupled infrastructure. And so you design something that is ephemeral, that means you can destroy it at any point of time. That also means you're suppressing the kill chain. If your application has been compromised, but you destroy and rebuild it every 24 hours, the probability that it's going to move somewhere to actually compromise you is very limited. That means you have a very different risk discussion towards the application. And you take those principles, that means that's the Verizon data breach reports looking at most of the breach in the world, the biggest breach in the world, and they find that 98% of all the breach have to do with those 9 things, right? So not fancy or nothing very theoretical. Stolen credentials, backdoors, unpatched vulnerabilities are really the core of what we are dealing with. You have stolen credentials, but you have the capability to rotate them regularly, and you actually rotate them regularly. You remove them from the code, you remove the risk. You're afraid about backdoors or rootkits in your environment. If you destroy and repave regularly, you remove the risk, right? So that means instead of talking about theoretical risk, we actually reduce by 98% our exposure to cyber attacks without spending a single dollar on security. And that's usually the great thing, because that means DevOps teams are actually delivering better security than your WAF, your fancy, expensive security tools, because you actually fix it to the core. So we usually look at it from a very simple approach, right? So you build your compliance in because you don't want to be dealing with it every day, so that people can focus on the value. But if you do 3 things, which is being very good at finding vulnerabilities and fixing them, because you have designed for loosely coupled infrastructure microservices. If you destroy regularly, and if you rotate all your secrets regularly, you've already reduced your risk massively without spending any dollars, without doing anything very advanced. And that's the core cyber hygiene you should be looking at today, your capacity to do this. And simple, not security, right? And that annoys a lot of the security vendors, because if you think about it, and if you talk about the adversarial testing or bug bounties, they will tell you, yeah, that's really, really killing the attack paths. And so, that's not theoretical. We have the largest companies in the world who are able to do it. Patching in real time. We have one of the biggest banks in the world who patched within 4 hours, 0 humans involved. So you were mentioning about continuous deployment. 0 humans involved because as soon as the patch is available, they inject it in test environment. The developers are practicing test-driven development. That means they know if anything breaks, they're going to have a test that's going to fail. That works, goes to production, 0 human involved. Within 4 hours, they patch everything. Talk about reducing your attack surface when there is no human involved and you patch within 4 hours, right? The same organization also destroys 3 times a week, because one of the biggest companies in the world. And the reason they do that is because they had a fire a year ago, the data center burned to the ground. Great. We all know that BCP DR centers never work as planned, and that's the case. Never data center, their backup data center didn't start for 4 days. So they took all the configuration, executed on their platform in AWS. In 4 hours, they were up and running with everything still running, right? So that's the capacity of repaving. Because if you destroy and rebuild, if you know that your configuration worked yesterday, your configuration will still work today. And that's the confidence. That also means that you, as developers, you know you can try stuff because you're not going to break anything. But the other reason they are sharing with us is because for years they've been struggling with those silent hacks, right? Nation states that plan 0 days and you don't really find them. And that's the reason why they want to destroy every day, because first thing is your application is compromised. It's not that great. It's not that great of an impact unless there is a lateral movement to something that matters. And really, by destroying every day, what they are aiming is to make sure that worst case, a container is destroyed. No, removing the persistence is already a very good defense because you don't have backdoors. But also that means that the adversary, if he really wants to go in, has to go very fast. That means your network monitoring will speed it up. But application that knows how the application works and can focus on detecting. No need for a theoretical SIEM that would never pick up an application level attack anyway. And that's the core of what we want to do with security, is fix the problem instead of adding layers and layers of security tools that actually create tightly coupled services and slow down the organization. So very quickly, we believe that in security should be about reducing risk, making security easy. And again, I'm a very big advocate of the Netflix model of paved roads, because they are really doing this, right? They're building all the security tools as part of the platform so that developers don't even know they're here, so that it's easy. And so that means when someone needs a new project, instead of saying, okay, should I use the latest fancy framework that feels like shiny and interesting, or should I use one process that is very steady and that works? Idea of, okay, I don't have to do the security discussion, yes, that works. It's usually very, very open, right? So you focus on detection.
Sorry, was there a question?
Is there a question?
Okay.
So you focus on detection. And if you look about it, right, in terms of activities that have to do with security, only a handful actually require security teams. Only to be done by the security team. And that's really the core of what DevSecOps is about, is enabling the developers to actually fix security themselves. I'll pass this one. You're familiar with our platform. And really, when we look at security at the application level, very often people try to find a tool for every single combination. But let's take the type of vulnerability we have one by one, right? Infrastructure vulnerabilities are still today the #1 reason for breaches. And that's I mentioned earlier, right? If you have cloud native, if you have the ability to patch at any time, if you can take your vulnerable Tomcat or vulnerable to Linux and just change it without even talking to your developers, then you've done a massive improvement in your security. Second source of vulnerability, the developers are not that bad, are usually third-party libraries. Again, very simple to fix. Software composition analysis today are very accurate tools. And even though I say, well, security tools in a pipeline are a dangerous game, you should always add the ones that are accurate, right? And so go ahead, take software composition analysis. It's very efficient, very precise, doesn't create garbage, and really reduce the risk massively. When it comes to code vulnerabilities, the easy answer is usually to put the SAST and the DAST and all the stuff, and let's face it, there are tools that don't really work that great, that annoy every developers because they produce more false positives than they produce real value. And everything they find will take so long to investigate and to find what actually the vulnerability is that it just stops your production release, right? So when it comes to those tools, they are extremely important and extremely valuable, but not as a blocking point in the pipeline. So the modern practice today is just to scan your repositories every 24 hours and take the output and put it in the backlog of developers so that they can work about it, and then you track velocity. Because you don't want to be blocking developers from doing their job. But in DevSecOps, we talk about shift left, right? And what's the most left you can do today in security? Question? Anyone has an idea what is the most left you can do to reduce the vulnerability being produced as early as possible?
Questions? Are there any questions?
Don't write the code, I guess.
I think we're good.
Yeah, we're good.
Yeah.
Sorry?
We don't have any questions.
No, I was asking the question. I'm asking you. What is the most left you can do to prevent the vulnerability being produced as early as possible?
What is the most?
In a shift left mindset.
What's the goal?
What's the most?
Sorry, can you repeat the question?
Yeah, so you're familiar with shift left, right? Try to detect vulnerabilities as early as possible. What is the most left you can do? How can you detect or prevent vulnerability as early as possible? I have a hint. It's written on the screen.
Coding.
Code.
Test, unit test.
Still not very left. The earliest you can do is to actually not write the vulnerability, right? So still today, among the value of, if you have to do security initiative for developers, do secure code training, because the best is you have people who actually know the vulnerabilities and don't do it. That said, what we see is that, and I have this issue myself, I've done quite a few secure code training as well, and I can guarantee you that when I write code, I still do vulnerabilities, because that's the last thing I have in mind. So what we see is a very big correlation between secure code training and pair programming. And the reason is, when you have two people writing code and the other one doing the review at the same time, and one is just focused on writing the code and the other one can read and has the training, it's easier for him to spot. I'm saying, hey, you forgot to validate your inputs. Hey, you have, no, if you do that, you would have a cross-site scripting vulnerability. And so really getting this practice of getting people together so that you can have different expertise is very, very important. Using secure frameworks, still very good. If you want to do what the leaders are talking about, using wrappers and all those things, it's great, but it's very hard to do. It requires heavy engineering. Still today, we have good practices in terms of development. If you use Spring and if you use Spring Security, Ruby has also some secure libraries. Just provide developers with those libraries and those practices and train them on it, and just make sure that people use them. You can still solve a lot of the problems with those tools, and that reduces a lot of the vulnerabilities, right? Still today, identity management, implemented identity management are a very big source of vulnerabilities in the code because it's hard to configure correctly or authentication unless the framework is taking care of it, right? So it's really about making it simple, as simple as possible. So I mentioned that rotation of credentials is very important for one reason. Developers have a tendency to put credentials in their code, right? Service credentials. We've seen it. GitHub 900 accounts wiped recently because credentials were in the code. Uber got hacked because AWS credentials were in the code. Removing the credentials from the code is extremely important. Having a secret vault as part of a platform, I wouldn't do without it. But really, it's not only about the secret vault. Your pipeline needs to be able to generate and rotate the credentials so that developers don't have to have anything on their code. If there is one thing that will never change in security is viruses and malware will happen on the developer's laptop, on everyone's laptop. Yeah. There's no secret in their environment. So it's really, when you build your pipeline, make sure that you can handle all the service credentials for your backend APIs, for your backend database and all those things, and rotate them regularly. Because if regularly you change those credentials and you've changed automatically without even telling the developer that the next time he's going to push this application, the credentials will be changed. He doesn't know them, so he doesn't care. And if you do that, let's say every week or every month, the probability is by the time someone hacks into your system or get access to those credentials, they will be already rotated. And that really changed incident management as well. Let's not forget, we're talking about ops as well. And today, incident response is still the biggest challenge we have in security. When we have a hack and when you have something, how do you bring down, how do you do your forensics, right? It's very hard. If you have an environment where you can change your credentials without any impact to your business, you can destroy the environment and rebuild it from clean every few hours if you wanted to. That gives a very different perspective on your incident management. Because you capture your forensics data and then you destroy. And then you can do your forensics and to find how you got hit quietly, instead of the shotgun on the head saying, you have a few hours to find how you got hit because we can't bring down the application, so we don't know if we have an adversary on our network. And that's really the core of why those principles of cloud-native architecture and developing better applications are so important, because they actually fix a lot of the security challenges we're dealing with today. Still, the most complex vulnerabilities to find today are those logic flows, right? You can do all those simple things that remove the simple vulnerabilities, but logic flows are hard. And that's really where we need to freeze the time of security, application security experts, so that they can sit down to do those threat models to say, hey, by the way, this is not properly assigned. When I worked in my previous roles, I can guarantee you our OPSEC were busy just managing the policies on the WAF or dealing with completely stupid operational issues instead of talking to the developers. And that's not what you want. What you also want is to do bug bounties, red teaming, all those things that allow you to learn vulnerabilities and improve. Right? Makes sense? Everyone's asleep? It's late. So you look at it, and so I won't talk about too much about right side, right? So pair programming and test-driven development are one of those funny things that are not about security, but actually massively improve security. You put your vault, do your training, all those things that are in the pipeline. Just put tools, security tools in the pipeline. Just make sure of one thing. The goal of DevOps is to increase velocity and to increase the productivity and the deployment frequency of your developers, because that's directly linked to your business generation. So you don't want to do security and stop and slow down everyone. So there is basically two categories: security tools that are very accurate and fast to run, no problem. Put them in a pipeline, block them if you want. Any other tool like a SaaS that really takes hours to run, or that generates so much noise that you need to spend some time to qualify whether it's a false positive or not. Scan the repository in the backend, take time to qualify them, and then put them in a backlog of your developers so they can work on velocity instead of blocking. This is very important to not block, because very often it's counterproductive. You slow down your developers, and you actually reduce your ability to work progressively. But regardless of all the tools you're going to use, you're going to have attacks, right? You're going to have vulnerabilities that still go through production. So it's very important to understand that part of DevSecOps includes also ops. Red teaming, bug bounty are practices that are fundamental to DevSecOps. DevOps is about creating feedback loops, and today we don't generate feedback loops for security. And red teaming, bug bounty, and I'm a huge advocate of chaos engineering as well, all practices that allow you to discover whether you had vulnerabilities, right? So the CISO of Etsy was one of the first to do bug bounty, and was very adamant on the value, because that gives you the opportunity to sit down with developers and say, hey, how could we have prevented it? And then they were writing tests to prevent it from the next time. They got another vulnerability and they realized the test was not perfect, and then they prevented it for the next time. But he didn't do only that. He also worked with his SOC and with teams like, how come we have a security researcher who broke into our system, moved laterally, and did a number of things and we didn't see any of it? And then he worked on improving their detection rates. The output was what? By the time the security researcher of the bug bounty was sending an email saying, I found a vulnerability, they had already detected it and had already fixed it. Yeah. And if you stay with me, this is exactly the goal of DevSecOps, right? Increase your ability to detect an attack or to detect a vulnerability that might be in production, and increase your ability to fix it. These are the two crown jewels that should be driving everyone in the security team and in dev team. And we go back to the basics of DevOps. As I mentioned earlier, the reason why DevOps work is because everyone focuses on those 4 metrics that are transversal, and everyone is compensated and incentivized to care about deployment frequency, to care about lead time. What I would invite you is to care about your ability to detect vulnerabilities and to care about your ability to fix it. But not only vulnerabilities, attacks as well, right? Because if you do that, you're good. If you're good enough that if someone is mingling with your system, you're able to detect it, adapt your response, and block it, as an organization, you're good. You don't really care the tools you're using. You don't really care the tools of tomorrow, because that means as an organization, you're good. That means if tomorrow you take your project and you want to pivot to use a different stack, a different tools, who cares if it's AWS or not? If your organization is able to do that, underlying is irrelevant. If you depend too much on tools, then the problem you have is that if tomorrow you change the tools or you change the framework, or like I've seen too many times, you're using a source code scanner that runs with Python, that runs with Ruby, but not with the latest framework or the latest language that one of the development team wants to use, then you're stuck. Right? And so this is really where it goes into the full circle, right? You start with security requirements that are simple because you start with an MVP. You put your pipelines, it's great, but don't forget the ops part of security. Yeah. Bug bounty and chaos engineering are 2 of the most effective ways to learn whether you're doing the right thing and whether you're good at detecting outage. You're good at detecting misconfiguration. You're good at detecting if one of your security controls doesn't work. And that's really why, if you think about it, I'll come back to it. The role of security is going to change in the next few years. As I mentioned, so you learn into different controls at different stages. You do your training, you do your threat model testing as part of a pipeline, but don't forget the operations, right? Don't forget to learn and to learn whether your application is running right or wrong. Let's be honest. Centralized SOC today. No need to take a picture. I'm going to send it to you. Centralized SOC today, and I'm sorry for whoever runs in the SOC, are almost useless, right? Because they will find very static rules, maybe detect a brute force attack, but they don't know if you've done a misconfiguration and you actually typed the wrong password, and so your service is trying to connect to the database and that's the wrong password, so it's a brute force attack according to security. They don't really know what's the right and wrong of the application, right? So if you take the model of those organizations and it really transfers towards building the knowledge of the application so that your application team or your DevOps team who knows what's the right behavior of the application can say, hey, that's fishy, that doesn't sound right. This service, I have 20 containers for my application for the front end, and one of them does something different, right? That's not normal, and pick up the phone and say, security, we might need you to help us. And there you bring things differently. And security, who looked at the threat intel, and please share your threat intel with the developers, can say, well, this type of attacks, right, we're telecom company, we can expect this type of attack, so let's go and make sure we have the anomaly detection so that our application team are able to detect if something happens to their application. And that's really the core of security will be, one, to build the automation and to build the tools that developers are going to use, and two, do those chaos engineering, do those bug bounty to drive the continuous improvement, to generate the feedback on whether what you have today is working or not. And that's really what we have. It's not only technical, right? Your ability to respond and to the difference between an attack and a breach is whether people work together. People are able to pick it up and within the 5 minutes say, I'm on it, I have an idea, I know where it is, here you go, right? If you have in an environment where your SOC has never talked to the developers or doesn't even know or spent the first 1 hour to find who is the owner of the app, this container runs on what server and all those things, is it normal that it runs this process or not? And you're already lost, right? So it's really about not only the technology but also the people. And that's why you should be practicing chaos engineering, you should be practicing bug bounty, because these are good ways of sitting back and saying, okay, we missed this one, right? Someone found a vulnerability, we didn't detect it, that's on us, let's go and improve. So I mentioned about 4 metrics of DevOps. I have my 11 metrics, and that's really what should be driving the goal of every security DevSecOps team. Improving your time to patch. And I'm not saying just patching for the sake of patching, but having the ability to patch at any point of time. If it takes you 5 minutes, then the difference is whether you patch or not is not a test, is a business decision. You decide whether the vulnerability is more important than whenever you want to release to production. And that's important. Working on the ability to detect an attack, detect a vulnerability is very important. You know that all the tools you shift them left, but will leave some vulnerabilities. So bug bounty, again, or doing your red team will find vulnerabilities that you missed, the logic flows that none of the tools will find. And how often you're doing it is really important, right? Release efficiency and accuracy of test suites might not look like security, but they are actually very important. Because if you block so much the developers that they spend most of the time doing security, then what happens is they're going to find a way, right? So nature finds a way, said in Jurassic Park, developers also find a way. And I know, because I've found a way to bypass my own security controls in the past. That's a reality of things, right? So it's important not to overdo it, and the accuracy of test suites really will make a difference whether the developers listen to you or not. Right? If you try to do stupid controls just for the sake of doing stupid controls because the industry tells you should have a SaaS ADAPS and every security tool on the planet, what you lose is credibility. In terms of resilience, it's important to be able to know that you can recover at any point of time, because how quickly you can recover is also the same on a security incident. If you're able to destroy everything and rebuild your business within a matter of minutes, because you have full redundancy and full immutability and everything is code, that also means from a security perspective, you can stop it in a matter of minutes, which is not true in most of the organization. So we see a direct correlation between test-driven development coverage and the number of vulnerabilities being produced. So please do your test, your unit test. Please measure whether you're doing 5% unit coverage or 95% coverage. The best in class, the ones who are able to patch without any human intervention and automate all those things, are close to 95 to 98% test coverage for their code. And that's really what drives the fact that they can ship code several thousand times a month without breaking anything, or that the platform team can change the infrastructure underlying without any worries that it might impact the application. And we look at it, right? Today, the difference is we had developers and infrastructure. Now we have DevOps teams, and the infrastructure is the DevOps team, right? So they need to be able to change the infrastructure without impacting the application. That's really where test-driven development is so important. So okay. Can you mute?
Oh, sorry about that.
Sorry, thanks.
Wrong button.
So, long story short, threat scenarios, do your threat model. I don't know if you do, but if you do, that's great. Because again, what you want is to develop security controls that are tailored for the app and that are meaningful for the app, so that the application team can pick it up and say, hey, I know this alert is relevant to this type of attack, so do it. If you have something that says unauthorized connection or like brute force attack, and your developers cannot map it to a typical risk, it's like it might be someone tampering with your backend or with your transaction system, that really doesn't have a repair. But very important, at the end of the day, I mentioned the principle number one of cloud native is immutable. Don't allow anyone to connect to production.
Sounds about right.
Yes. Okay, the reality is you will always have things to troubleshoot. There is a very important thing. If you connect to production, that means you're missing telemetry. You shouldn't have, as a DevOps team, you shouldn't need to connect to production, because you should have enough telemetry in the backend so that you can investigate without finding an issue. True about security as well. But when we find that there is always something missing, so you SSH into the box, you actually look at the logs and all those things. That's not a problem. As long as someone right after finds the problem, goes into your code, fix the configuration, push a new version of the app and destroy everything, you do not have a security problem or an availability problem. You don't have a snowflake configuration. But if you start doing troubleshooting and configuring things here and there, this is where, you know, those outages that no one ever planned happen, because you forget to change the configuration, or you have 20 nodes, you change 19 and you forget one, right? And so that's why it's so important to say, from a security monitoring perspective, someone connecting to a machine might not be a problem if you push a new version of the app right after. If you don't, trigger a security incident because you have a snowflake configuration running. So what you will see when you do DevOps, because you have different teams and all those things, that it goes at different paces. Some people will fix some of them faster than others. So the role of security and risk is to look at the different trends of all the different teams. It's not to try to set up a benchmark for everyone. Some of them might not have the same risk, right? But trying to incentivize behavior, if you see that everyone is not improving anything on the time to patch, and management can go and take a decision because that's where the risk is. That's not because you have 5,000 vulnerabilities in your application is whether you're not actually working on fixing it. And so the role of management is really to look at the different teams and making sure that things are going smooth and you have the continuous improvement. So, last minute, we're going to have a massive change in how assurance practices are going to be done in the future. A lot of security until now, because of banking, was seen as a control function, second line of defense. So kind of the tell you that you are wrong, but doesn't take any skin in the game in actually building stuff. So with the practices that cloud native companies are doing, we see a massive change in how you do assurance, right? So in terms of outcomes that companies are looking for, we summarizing the 5 S's: the speed, scalability, stability, security, and savings, right? In terms of speed, that's really the 4 metrics of DevOps that tells you whether you're best in class or whether you're lagging behind, right? If you have poor lead time and poor deployment frequency, you know you need to work on that. In terms of scalability and stability today, SRE practices have kind of become the benchmark on being able to measure whether you have the right availability and the right scalability with availability budget, error budget, if you're familiar with SRE. And that's really kind of becoming more and more the practices where you don't have a separate function that measures, but you have actually teams that improve the assurance, right? And that's where chaos engineering comes into play. If you look at a lot of those metrics, and I mentioned earlier, time to restore. Time to restore is great, but if you never have an outage, how do you measure whether you have time to restore? In the old days, what we were doing is that we kind of prayed to God that we'd never have an outage, and when it happens, it takes you hours and hours and hours because no one has ever investigated an outage, right? So all those cloud companies are now massively working on chaos engineering to introduce those failures. One, to be able to test those small weaknesses that one-to-one accumulate to become a big outage, but more importantly, to create people who are trained, who are very sharp and good at doing those investigations. They see a signal, say, I know what it is, we had the case a few months ago, and go investigate and fix it before it actually becomes a very big issue. Most of the issues you have when you deal with high traffic are actually a sum of small inefficiencies that rolling service by service by service impact each other. So you might have a slow performance service at one point that over time will start timing out and crashing the rest of your backend, right? And that's really where it's important to do those practices. In terms of security, 3 R's: repair, rotate, and repave. If you do those 3 things already, you're quite good in terms of maintaining the infrastructure security. And do your bug bounty, again, chaos engineering, bug bounty, red teaming are very, very important practices on the upside of doing security. For the cost savings, I can't do anything, just talk to your CFO. But if you actually do that, and if you reduce the overhead on your developers and on your operations so that everyone is very efficient, you create value, and you don't spend security tools that you would typically do, then your CFO will be happy. That makes sense? So what we see is more and more teams that are dedicated to platforms, to build platforms. So some people might call it SRE, we call it PRE, that really builds a platform and maintain a platform that are used by developers, business developers, so that it's several teams of that do work and develop, and security start to develop services. So I'm only allowed to talk about the ones that are public. So T-Mobile, for example, the security develops an IAM solution. So they take their OAuth authentication, the normal one, and they put the wrapper of all the roles, governance, and all those things. Instead of doing the access review and all those stuff, they've created their own internal governance and a wrapper around it. But also mean when you have a threat intel that says, hey, by the way, this account might be compromised, they don't have to deal with anyone else. They have full control on the identity service. Same on encryption and all those things. So they built their own services so that developers can use them, right? So that's also what Netflix is doing, building services that the rest of the organization can test, because that's more efficient than trying to retrofit security controls on different aspects. That's it. DevOps is in the pipeline. Security is in the pipeline. I don't want to talk too much about the pipeline because you have so many vendors who are going to do the job who are going to do that. But if there is one key takeaway is don't forget the upside of security. Don't forget that at the end of the day, DevSecOps is about enabling your DevOps team to deliver good code, secure code, and react, right? So do your bug bounty, do your chaos engineering, learn from it, and fix the issues one by one. You will have greater outcomes than if you try to buy every security on a market. And that's it.
Right.
Thank you.
Thank you.
Jerome, I just have one question.
Sure.
This is RR from ISDP, Security Department of Globe. You keep on mentioning this is how Netflix do it, blah, blah, blah. Can you share some reference for me about that success stories of Netflix?
Yeah, if you want, I mean, Netflix is not our customer, so don't really think I'm trying to pitch us, right? It's why I love Netflix overall is because they're very open to what they do. So they have a blog, and their security team writes about it. So if you want to go to understand what they do,
We can send them.
just go and Google paved road Netflix. So that's their philosophy, right? They build a whole philosophy on the paved road, on building the tools that everyone else will do. So how it started is just the CISO said, I'm not going to block you from doing anything. You developers are the one generating the business. Only requirement is use these tools, and I'm not asking questions. Or if you don't, you sit with me, and we're going to have a discussion on how we secure it, right? And so overall, he started building those services to embed security, and he created a whole philosophy of like, my goal is not to block you, but if I tell you you have 2 hours to fix something, you have 2 hours to fix something. If I tell you you have 3 days, you have 3 days. And if you pass this limit, I'm going to shut down your service. And if you're familiar with Netflix, they are the one who wrote the Chaos Monkey. So they don't really care about shutting down services. They do that very regularly. And so it created this trust and this relationship. I can't really give you the details, but a lot of this is because I met and I talked regularly with their first security engineer in Netflix, and so it was really the philosophy. But I would say just go read the blog, right? They are very open on their philosophy. They've went on talks very often, meetups in the US, and everything's on YouTube. They're not the customers. They're not the only way to do it. A lot of security people will tell you, well, we have another way to do it. But it's a good view on a different way of approaching security.
All right.
All right.
All right.
Thank you, Jerome.
Pave, you have another question?
I have another question, sorry. This is Erwin from the software development team.
Sorry?
Yeah.
Maybe, sorry. Based on your experience, if you have to choose say for example, a framework that we can use for application development, which one do you think is well, I guess from a security standpoint, is the more secure framework?
Well, the problem that is going to be a very biased solution because I joined Pivotal, so there is a reason why I did it. Let's rewind back. It's not about the product itself; it's about the abstraction layer you're trying to achieve, right? Mm-hmm. If you think overall, we have in a typical data center, it's great what I mentioned about immutability and all those things. That's the fundamentals of cloud native, right? So if you have stateless application, that's easy to do. If you have stateful application, that's a little bit harder to do. So typically, you would have three level of things. What you mentioned earlier, functions, or as we frame it, event-driven architecture, is kind of the summum emerging, not mature yet. But from an immutability and ephemeral perspective, a function is a container that runs for 5 minutes and is being destroyed after. So a lot of the security threats you have are completely gone, because if it gets compromised, who cares, right? So it's more, your approach would be more about end-to-end mapping the chain of events and how all those buses come, and how you might just use a function to inject into something in the back end. So that's very complex vulnerability, and that's why a lot of the security will tell you, we don't have a good security model for functions, right? Access management today is the way you do it. Cloud native, then take cloud path, right? Application services will give you all the builds so that you don't have to look into the content of your container. So the problem we have today is most of what's on Docker Hub, all those predefined Dockers you're going to download contain malware, contain vulnerability, so they are a pain to do. Easy to use for developers, but a pain from a security perspective. Use an application platform, the platform builds it for you. So honestly, you just have to deal with the code, and platform does the rest. Will enforce mutual TLS authentication, micro-segmentation, and all those zero trust that we were dreaming about in the old world. Then you go, if you can't do it and you need to do stateful, then that means you're stuck with Kubernetes, right? My employer might not like it, but who cares which Kubernetes you're using? Just don't build it yourself, because
it's going to be very hard.
Or the stuff, you have higher chance of making mistakes and making stuff. We have a colleague who made a calculation on CNCF, right? If you take every component you need to build a Kubernetes, working Kubernetes, there is over 1 billion combination of all the different components, right? So it's hard to build yourself. So just take a platform, Kubernetes, and then focus on the additional controls of the content of your containers. Introduce your service mesh, please. And for the rest, for your legacy system, there is a model I usually recommend, is to try to take everything that is internet-facing or user-facing and completely remove any connection to the legacy system and try to refactor through, I call it IDEA, and not So you take immutable, distributed, ephemeral. We talked about destroying and all those things, but a very important factor is authentication, right? So today you have adaptive authentication that are pretty good at knowing whether the connection comes from a malware on your laptop or man in your browser, or whether it's a real user, if you do your step of authentication. If you guarantee that 100% of all your endpoints that are supposed to be authenticated are actually like internet or user-facing, are actually using an adaptive authentication, that means that even if you have a vulnerability, you know who it is. It's one of your customer or one of your staff. And the probability that they're going to try and mingle with the application and try to do an SQL injection is much lower than if it's public and usable by, accessible by Russia or something like cyber criminals there. So if you do those, if you refactor all your front ends, be it internal or external, to microservices, then you've dealt with your legacy, because you will have less noise, less connections to it, and all those things. So it improves your infrastructure overall.
Okay. Thank you.
I'll just add to what actually Jerome mentioned, right? It is actually based on his idea of protecting iteratively, right? So, I mean, whichever framework you choose, I would very strictly see how good are they in actually providing, or how quickly are they actually able to heal the vulnerability. So vulnerabilities are not going to stop, right? When you write a line of code, it is already vulnerable in one way or the other in ways you don't know, right? So once a vulnerability is discovered, how quickly that vulnerability is actually patched and how quickly that patch becomes available to you, I would actually look very deeply at that, right?
Yeah.
So whatever framework you consider, that should be one of the criterias from a security aspect. Now, Jerome also mentioned about the authentication aspects of it, right? And we see, at least I as an engineer, I've seen so many bad implementations of authentication protocols, likes of OAuth and OIDC. So I would say don't try to implement it yourself. Actually use a proven library. And actually, Spring does a great job, frankly. The Spring and Spring Security, those two things, they do a great job of actually providing you with a lot of protection. So, then a common concern comes out to be that, hey, you know what? Spring is Java, but my application is not. Okay? So that's where we actually have, I don't know how much of Java community do you follow, but there is a Spring Cloud Gateway that was introduced as a product. You can actually leverage it as a cloud gateway. So you may be implementing your application in Python or say .NET or in something else. But what you could potentially do is you can actually have essentially a component, which is a Spring Boot application, sitting right in front of whatever application or the microservice that you have built. And you can leverage the capabilities of this to do all sorts of your security procedures. And thereby lies your opportunity. So you can really have a consistent security layer across your applications, even if they are not written in Java.
Good. Your turn.
Thank you.
Thank you so much.
All right. Take care.